Okay, today, guys, we're going to start on our very first section, which is 1-1. If we had it, so we don't have that, we can do 1-1. Or actually 2-1. Anyway, okay, we're going to study polynomials today and some other fun facts about them. What does poly mean? Multiple or many, right? Many. I'm pretty easy going. I can figure it out because the handwriting very easy. Okay, here we go. So, I'm going to write an equation here, multiple of them. These are all functions. One, two, three, all of them or none of them. Which one is the polynomial? Think in your head. Think in your head. The first one, the second one, the third one, none of them, or all of them. Okay, how many of you guys raise your hand if you think it's the first one? Nobody's brave enough to answer that one, huh? How about the second one? See there? How about the third one? See there? How about all of them? Two of you. How about none of them? Well, the person that said number two is that. Okay. The first one is not a polynomial, it's a service function. The third one is not a polynomial, it is a rational function. Okay. Now, what makes something? How I just did my problem. What makes something a polynomial? It has one or more terms with the variable being raised to a whole number. What's a whole number? Our natural numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our whole numbers are, it includes 0. So 0, 1, 2, 3, 4, 5, 6. Polynomial is, once again, many terms coming together that has your variable being raised to a whole number. Okay, so I'm going to go through and just start writing it. You guys tell me whether it is or not. Is it a polynomial? Why not? One term, that's still many though. Many. Does it? Does it? Zero's a whole number. This is a polynomial. Okay, it's called the constant. So y equals 7. Well, it's just a 7. It's just 7. That's just a number, right? So we're asking what kind of term. What is this called? It's a constant, but it's also called a monomial, meaning there's one term. Monomial. Well, once again, we're talking about our variable. So on this one, right here, notice if you look at this one, this guy is 2x. Come on, work with me.
Click the select button.
Right? Is that a whole number? That's an integer. So this guy and raised to a half, which is a rational. So any number is going to be a constant. What does a constant look like? Horizontal, right? Always consistently that same number. Okay? Now let's go to the next one. Huh? That I don't care about that. That could be a half. Sure. It could be negative a million for all I care. I'm not raising that to the power 0. I'm raising its variable to the power. Because it's the same thing. This and this are the exact same, correct?
You have an x in there.
Exactly. What's x to the 0? 1. Anything raised to the 0 power is 1. 1 times 7 is 7. Makes sense? Okay, so let's go on. If you need something else, I can help you. What's that called? A linear. Okay, because what's our highest power? 1, right? We actually can describe this. This is a linear power, a linear term. This is its constant term. So they actually have, each part has its own name as well, yeah. Sure. I guess it could, but I don't think that. You could even have different variables to do it. Like, for example, that's still a polynomial. What's its degree? And you guys might not know what the word degree is, but this is degree 4. So I add those together.
So if you have what's that called? Square root?
Square root, brother.
And that's not a polynomial.
It is not.
But can you add an x on it and make the power 0?
But then therefore, so if I have square root of 2 times x to the 0, that is a polynomial. Because once again, my definition, what was my definition? A variable being raised to a whole number. Not the constant, not the number. This is an irrational number. That's not the same. Now, if it was x plus 2 underneath the square root times by x to the 0, that's not a polynomial. Because that x is not being raised to a whole number. Okay, yeah, I'm gonna get there. I'm just they're still stuck on, he's a little stuck on 0 farther. So I'm just trying to help. I was making sure you're clarifying. I'm not talking about the constant, but I'm talking about the power happens to be a whole. Well, once again, is it an equation? It's not just a number. It's an equation. A polynomial is an equation. Does that make sense?
So what if I put parentheses on it? Whatever equation you use, it does whatever it needs to do then and by having to do it.
Okay, but once again, okay, I get what you're saying there, but I'm wondering if you're trying to say anything. X cubed plus 4x plus 3x to the half. Is that a polynomial? No. Why? That's polynomial parts, right? Because the half. The half makes it not a polynomial anymore.
But if you have parentheses on it,
It doesn't, no. See, that's where you're getting off. That's not what I'm doing. Okay, so what I'm trying to say, just because if I throw this sucker right here, does that make him a constant? No. Because then that's just 1, and 1 times this is still not a polynomial. Right? So let me get a little deeper, and that might help you where it's at. You're just worried more, I think you're into that I just threw up x to the 0, which is 1, right? But is it still a variable being raised to a whole number? The key thing I'm trying to get to is anything that has at least a variable to a whole number. Okay? So, here, my variable, is it raised to a whole number? Yes, 1. So therefore, is it a polynomial?
yes.
Yes. What is this? Is it a linear binomial? right? Okay, how about this guy? Is all of those terms within that a polynomial? Yes, or is this whole thing a polynomial? This is what kind of polynomial? A trinomial, that's true, but it is a quadratic. Quadratic trinomial. Somebody answer that question for me. Everyone else? What makes this linear? The highest power is 1. How about this? Oh my goodness! The polynomial. Yeah, what kind? Cubic monomial. Okay. Everybody with me? Are we doing okay? We getting better? Okay. Is that a polynomial?
Yeah.
What is it? Quartic is what we call it. After that, I don't know the words for them. They don't really use them. They use anything up to that. They call it fifth degree, sixth degree polynomial. Does that make sense? Okay. What do we call this? What kind is this? There's 4 terms. 4-term polynomial. Anything after 3, they just say however many. Make sense, everyone? So this would be a quartic. Let me write that out for you. Like a quart. Quartic, and it's a 4-term polynomial. Okay. Everybody with me on polynomials? Is this in standard form? You guys remember what standard form means? No?
Move truck, what do you got for me?
Highest term. So right now it went highest, and then we missed the next highest, right? So because see how the cubic is next, should be next, and it's not. Can we put it in standard form though? Because once again, addition is commutative, we can do so, right? So therefore we go x to the 4th plus 4x cubed plus 3x squared minus. Right? Good? Good? Oh, I could be on drill. Did you see that? That was like perfect motion. My sister was one. So was my mama. She was a minorette.
What am I at?
Bingham minors. At female minor. Why are we thunderettes, I wonder? Well, the very first year they called me Bingham. Did you ever have a new? No. That's what it is. Interesting. The storm is what it, yes. Okay. What else have we got? 4th period. Oh, okay. Nice. Degree. I brought up the word degree after quarter, right? What does degree mean? So on that last problem I had this, or let's write it up here. Let's just have a new one. We'll make that new. That's an 8.
Okay, what degree is this? It is a 5-term polynomial, so we don't just call it by its degree. This is an 8-degree polynomial.
Only if you add them together, there's multiple variables within one term. So like that one that I wrote up, that's a degree 4 because they're within one term. It's not separated terms. The highest power available in the polynomial. So because 8 is the highest power, that makes it an 8th degree. Okay? That also tells us what the graph looks like. Okay? Huh? Not necessarily 8 bumps. Yes, Kayla. I can at least try. Uh-huh. So the difference between that top one and this bottom one is those individual terms. This term, it's only x's, right? This term's only x's. X's. X. And an x. Technically, x to the 0, right? So each term had their only one variable with them. That bottom one, how many variables are within one term? 2 variables, x and y. So therefore, you would add. Does that make sense again? So it would still be. Oh, why am I doing this? So if I turn one of those up into a y, it's still. I would never use a y because that's kind of like that. We really don't study ones very often. But yeah. So if this was the case here, that would still be turned power 2. Does that answer your question? Yeah. So the 8 would still overpower it. Okay. So, with that being said, we can tell what this graph looks like. And I'm going to kind of prepare you for what this graph looks like. Because we're going to think about it. A line, what does it look like? That's a good line, isn't it? Yeah, I don't know what's going through it. Okay. Shush. Okay. Then, what degree is a line? Degree 1, right? Because a line like that would be 3x plus 2 or something. Okay? Where our highest power is 1 plus 2. So, notice here it has degree 1. 1. How many turning points? We have no turning points because notice it's consistently increasing the whole way or consistently decreasing, meaning it never changes, correct? No turning point. How about a quadratic? So let's say I just have even x squared, y equals x squared. What's its degree? Degree is 2. And our turning point, let's just show you, basically this is what it looks like, right? As 1, because notice I'm going from decreasing, and this point changes from decreasing to increasing, that is considered a turning point. Okay, so this one has degree 2, but we have 1 turning point. Okay. How about an x cubed? A lot of us don't study x cubed. A lot of you guys haven't studied x cubes, right? So let's look at the most basic one. The most basic one looks like this. How many turning points? 0. Always increasing. Here's another graph that is x cubed, more like this one. How many turning points? 2. So notice what's the degree of him? The degree would be 3. How many turning points could we have? Turning points could be 2 or 0. Could not be 1. Why could it not be 1? Because if I have 1, it wouldn't have this end behavior. It wouldn't have this part of the graph. Notice the body of a cubic is different, but this was the same, wasn't it? that make sense to everyone? This part. And if I only went to one turning point, I have to do something like this, which that changes the whole concept of that graph, right? Does that make sense to everybody? Okay, really quickly, let's go on to one more. And then I'll ask you a generalized question. Okay, x to the 4th. What's our degree? So once again, we all understand the degree is the highest power, right? Turning points. How many could I have? 3 or 1. Let me give you an instance of 3. Here's an instance of 3. Okay, that could be an example of a quartic. Here is an example of the most basic quartic. But see how it's a little flatter than a parabola? Instead of more of a U shape, it starts flattening out a little bit because if you think about it, 1/2 squared, what number is that? 1/2 squared. 1/4. But what's 1/2 to the 4th? 1/16. So notice the small numbers between -1 and 1, fraction things, right? Not just fractions, but numbers less than 1, the absolute. The numbers that are less than 1 for the absolute value of x. There we go. That's in between -1 and 1. If I raise those to any power, they get smaller as the power gets higher. Does that make sense? So it basically looks like it's flattening, but is it flat? No, it's just coming down very narrow. Okay. Right, but notice, one more question. How many turning points? 1. And how many turning points? 3. Okay? So, but once again, turning points, did it change the basic graph of an x to the 4th? This is the basic part. The body was different, but this was the same. Right? Does that make sense to everybody? Yeah. We'll get to that a little bit later. Now, really, turning points, you could actually find that out more like detailed from the equation without graphing it in a in calculus. There's actually ways to show you, but we're not there yet. Okay. But we're going to talk about the possible turning points. And remember, why am I going down by increments of 2? Because if I do one less than just what I have, so I can't have 2 turning points, because 2 turning points, remember, I'd have this, bounce. I'd have to have 2 turning points all in. So I'd go down, up, down. That changed my whole graph. Does that make sense to everybody? Okay. Let me hear you ask you this question. What if I had, one more second. What if I had x to the 17th as my degree? What would be my degree? What's my turning points? What's the most turning points I could have? What's the least turning points I could have? 0. Because I could have 16, 14, 12, 10, 8, 6, 4, 2, 0. They're all even. Exactly. And we're not going to. All you do is go 1 less than the degree, and then increments of 2 down. So because once again, if I did, so for example, x to the 17th, and I went 15, that changes me from something like this, because x to the 17th has this kind of shape. But if I had 15 of them, I'd have to be this or this. Does that make sense? You with me on that?
So would it be opposite? Like if I have like would I go x to 15?
I wouldn't go x to 15, but I'd have 15 turning points. 15, 13, 11, 9, 7, 5, 3, and 1. Those are the possible turning points. I always have to have odd turning points on even, or they wouldn't be even anymore. Because once again, what does an even kind of look like? With your guys' arms, show me with your arms what an even basically looks like. All evens have this shape. The body might be different, but this is what their end part's going to be, right? Does that make sense to everybody? Just think about it. Anything raised to an even power is always going to come out to be positive. Negative numbers raised to a even power is a positive number. Negative number, excuse me, that's positive. What the hell did I just say? Here we go. So, even numbers raised to a even number. Say that right. Positive numbers raised to an even number come out positive. Negative numbers raised to an even power come out positive. So I'll always have the shape. Once again, the body might be different, right? But it'll always have the shape. Okay? And if I didn't, so that's automatically one turning point, right? I have to have one turning point for an even automatically, doesn't it? Does that make sense? On odds, do I have to have a turning point? I don't. Okay? Does that make sense to everybody kind of where we're going at? So with that being said, what does a leading coefficient mean? The highest power, okay? So let's say here, y equals 2 minus x squared. What's our degree? 2 because of him, right? What's our leading coefficient, even though it's not in standard form? -1, because if I put this in standard form, -1 would be the leading coefficient, right? Now, this is an x squared, so that's an even function. Looks like this, right? Yes, because it's even, but no, because what's my leading coefficient? Negative. What does that do to my graph? Boom. Right? So knowing our degree and our leading coefficient, we kind of have the shape of what the graph should look like. If it is an odd degree with a leading coefficient that is positive, that should be looking like so. If I am a odd degree, that is a leading coefficient that's negative. Flips me, doesn't it? Just think about that. What's a positive? This is as x going to infinity. Okay, as x is going to infinity, so a positive cubed is a positive, but then all of a sudden I have a leading coefficient that's negative. A negative times a positive is a negative. This was down because a negative number raised to an odd power should be negative, but a negative times a negative is a positive. So once again, let's go through them. What does this give me? Even number with a positive leading coefficient, correct? Even number, even degree with a negative leading coefficient. Odd degree with a positive coefficient. Odd degree with a negative leading coefficient. Everybody with me there? Okay. Now what I'm trying to say by this is leave. How much time do I really have, guys? I know I should be out 15, but my clock's off. So where am I at? 4 minutes. I got 4 minutes. Okay. Stick with me for 4 minutes. If you have questions, please stay after just so I can get through some material, okay? So really quickly, let's say I had x to the 4th minus x squared. What that looks like is something like, looks like that kind of. You know, it's kind of weird. Okay? But what I want to talk about now is end behavior. And here's what end behavior means. As x goes to infinity, so as x goes this way, what's happening to our y graph? It's going up. Which way is up? Increasing, which is to infinity. It is not as x goes to infinity, y is going to infinity in this graph. You guys agree with me? How about as x goes to negative infinity? What the heck is that? I'm struggling today. As x goes to negative infinity, y is going to infinity. Now, I don't have a lot of time to get into this big detail, but I'd like to ask you guys this. On evens, shouldn't I always, my end behavior be going in the same direction? Either way. If I'm negative, as x goes to negative infinity, it's going negative. As x goes to infinity, negative infinity. Does that make sense? What about an odd? As x goes to negative infinity, y goes to negative infinity. As x goes to infinity, y goes to positive. They're always going to be opposites, right? So, really quickly, we're going to do this by ourselves. Y equals 3 minus x cubed minus x to the 5th plus x to the 9th. I would like us, without graphing it, but thinking about what the graph looks like in our head, What is our, those infinities are horrible. What is our end behavior? So you have to ask yourself what? What's the first thing you're going to ask yourself? What's the degree? The degree is 9. Okay, so that is an odd degree. What's my leading coefficient? 1. So that is a positive, right? So with your arms, really quick, 1, 2, 3. This way, right? Is everybody with me on that? As x goes to infinity, I will be going up. As x goes to negative infinity, I will be going down. So as x goes to infinity, what will y be doing? It will be going to infinity because here, as x goes to infinity, I will be going up. As x goes to negative infinity, this way, right? Y will be going down or negative infinity. Okay. I would like to get to this next example. I don't know. Can you get that one now? Half a minute's not going to make it then. We're not going to do it. So there are going to be 2 things on your homework that we did not get to. They're differences. Okay. One thing is common differences. Huh? I usually don't. I didn't put anything on the card till after. I don't usually do that. If I know I need to do it, is that fair? Did I do anything that wasn't fair today? I think everything I taught you was on the quiz, right? Huh? Okay, guys, have a great weekend. Huh?
Georgia and Jackson Fox sitting out there. Georgia and Jackson Fox.
We got help yet. From me? Awesome. Does that mean that's me? You see, did I answer your question in the end, Tyler? I don't know if it's me. Will you just go sit up on my desk? What's that? No, I don't have a grader. No. I don't have time to grader my class. That'd be way too much time. Hey, I like you know what? Sure. No, well, that's still going. I need this now. So this is not a polynomial, correct? It's not a polynomial. But